Okay. Hello, everyone, and thank you for joining us for tonight's Lake Ontario evening, which follows the progress of Summit Toronto and Region's largest waterfront projects. Tonight is part one of a two-part series, and we'll be focusing on projects in the east. Part two will focus on projects in the west, and that will take place a month from now on March 23rd. And registration for part two will be made available through our Remedial Action Plan website, the Toronto and Region Conservation Authority events page, or through social media, which I will share the addresses for at the end of my presentation. My name is Don Little. I'm the acting program manager for the Toronto and Region Remedial Action Plan, which hosts these events. Lake Ontario evenings such as this are part of a speaker series, and they take place typically 3 to 4 times a year. Always on a variety of different topics related to the Toronto waterfront or the larger Great Lakes system. This is our agenda for this evening. So as you can see, we've got a great lineup of speakers tonight and presentations. But before we get into our talks, my co-facilitator for this evening, Tisha Tan, who is a community learning coordinator at Toronto and Region Conservation Authority, will start us off with some housekeeping, followed by a land acknowledgement.
Thank you so much, Don. Everyone, welcome to our webinar tonight. If you are joining using a phone or another mobile device, and you notice you can only see either the webcam view or the slide view, all you need to do is just swipe on your screen and you can swap between both views. Everyone in attendance tonight has been muted to limit background noise, but that doesn't mean we don't want to hear from you. So if you have a question for any of our speakers this evening, feel free to answer it in the question box. You'll notice a Q&A button or option, and that's where we'll be keeping track of questions. We'll address questions for our speakers at the end of each of their presentations. If we don't get to your question during a specific Q&A period, then we'll try to address them at the very end if we have some time. Also, if you're having any technical issues during the presentation, please use the chat function to message me directly. You'll find my name there, Tisha Tan. You can also contact me via email if the Zoom chat is not working for you. So my email should be found in the email from Zoom where you found the link to this presentation, and I'm just going to put it in the chat right now as well. And finally, this webinar is being recorded. The recording will be available on the Toronto and Region Remedial Action Plan website at torontorap.ca, and we'll be emailing a link to that page following the presentation. Be patient though, because sometimes it takes a few days for these videos to sort of buffer and get added to the website in time. So just give it a few moments, but all of that information will be shared in this follow-up email. Okay, so we'd like to begin our event this evening with a land acknowledgement. Although we find ourselves geographically dispersed today, meeting here in this online environment, I'd like to begin by recognizing that we all work, live, and gather on traditional Indigenous territory. Toronto Region Conservation Authority, or TRCA, respectfully acknowledges that the lands that we're situated on are traditional territories and treaty lands, in particular those of the Mississaugas of the Credit, the Anishinaabe, of the Williams Treaty First Nations, the Huron-Wendat, the Haudenosaunee, and are now home to many diverse First Nations, Inuit, and Métis people. So through our work with land and water resources within the Greater Toronto Region, TRCA appreciates and respects the history and diversity of the land, and we're really grateful to have the opportunity to work and meet in this territory. We're also grateful for the continued work of many Indigenous peoples who are the original caretakers of this land, and we humbly acknowledge our responsibility to respect Indigenous perspectives and elevate Indigenous voices. So we invite you to acknowledge the territories and treaty lands in your local area, and we encourage everyone to explore the interactive map at native-land.ca if you want to learn more.
Great, thanks. Thanks so much, Tisha. So we usually kick off these events with a couple of just quick poll questions just to see if folks have attended Lake Ontario evenings before, also to see how familiar folks are with the remedial action plan. So Tisha, if you don't mind bringing up our poll questions there.
Has it launched?
I'm not seeing them on my screen, no. Oh, yep, there they are.
There
Perfect.
we go.
Yep, got them. Thank you. Okay, so our first question, is this your first time attending a Lake Ontario evening? And then our second question, are you familiar with the Toronto Region Remedial Action Plan? So we'll give folks about 10 seconds or so to fill in their responses, and then before we move on here. So. Okay, so Tisha, if you don't mind closing the polls there, and I don't know if you can display the responses. Perfect. Okay, so it looks like we're a fairly evenish split here. So we do have some folks joining us for the first time, and some folks who are unfamiliar with the remedial action plan. So that's great. Great to see that we have so many returning participants. So welcome back. Also great to have new people joining us tonight. So one of the goals of these events is to spread the word about the remedial action plan. So again, it's great to have so many newcomers. So and for those who are joining us for the first time, I will provide just a very quick introduction to the remedial action plan, what it is, how it came to be, and how we're working to contribute to a healthier lake and Toronto waterfront. So the Toronto Region Remedial Action Plan, it came out of a process that started in the late 1980s when Toronto was identified by the International Joint Commission on the Great Lakes as one of 43 areas of concern in Canada and the US. And areas of concern were defined as areas where local environmental degradation posed a threat to the larger, or to the Great Lakes at large. And each of these areas of concern was measured up against 14 potential uses that could be impaired, called beneficial use impairments. And in Toronto, 11 of the 14 were attributed, and originally 8 of these were deemed impaired, and 3 required further assessment, as this slide here is illustrating. So the goal of the remedial action plan is to address these impairments and to ultimately delist Toronto as an area of concern. So the remedial action plan, or also commonly called the RAP, is a unique plan for each area of concern, which identifies actions that have been or are to be implemented by RAP partners in order to address each of the remaining impairments. And in Toronto, we've made great progress in the last 30 years by working with partners to implement actions that improve water quality, aesthetics, create and restore fish and wildlife habitats and populations. And as a result, 5 of the original beneficial uses are no longer impaired, and progress has been made on the remaining 6. So some examples of these actions include sewage and wastewater treatment plant upgrades, which we will hear more about tonight, aquatic and terrestrial habitat restoration across the area of concern, including 44 aquatic habitat sites guided by the Toronto Waterfront Aquatic Habitat Restoration Strategy, implementation of beach management plans, litter cleanups, and a variety of outreach and education activities, just to name a few. So if you'd like to learn more about these or other RAP projects, or you'd like to view our work plan to see how we plan on delisting as an area of concern, you can visit our website at www.torontorap.ca. You can follow us on Twitter at @rap_Toronto, or you can email me directly using the address on the screen here. So that concludes my introduction to the remedial action plan. So without further ado, we will get into our talks. So our first set of talks will focus on upgrades to the Ashbridges Bay treatment plant, with our first presentation highlighting the new Ashbridges Bay outfall, and the second, the new landform. So our first speaker tonight presenting on the outfall is Kevin Maher with Hatch. So Kevin is a senior project engineer, project manager, and associate with 17 years of experience in design, contract administration, and construction supervision of municipal water and wastewater projects. Kevin specializes in pipe design, hydraulic modeling and transients, trenchless technology applications, and tunneling of large diameter water mains, sewers, and outfalls. He also has expertise in project management, construction, cost estimating, and scheduling, and construction contract law. So Kevin, I see you're already sharing your screen, so that's great. And whenever you're ready, you can unmute and take it away.
Don, thank you so much for the introductions, and I absolutely appreciate the opportunity to talk about what's considered generally a low-profile project, but has great success so far, and we look forward to continue making a positive change to the Toronto area with this construction project. I'm here to talk about the Ashbridges Bay Treatment Plant outfall, and I'm going to give a quick update on the project and at least explain the overview of it, and then give you an update of how we're going on construction so far. So without any further ado, again, my name is Kevin Waher. I work at Hatch, many different roles and responsibilities. I actually went to University downtown Toronto, so I know the area quite well, and born and raised in the Niagara region, but now living locally here in around the Toronto area. So it's a pleasure to be working on this project, a significant project within the city of Toronto. And now I'll start with my slideshow kind of goes through what the purpose of this outfall is and how it fits. If any of you are not aware, the Ashbridges Bay Treatment Plant is one of the largest and oldest wastewater treatment plants in Canada. It treats a lot of wastewater effluent coming from the residents, about 1.7 million residents, which effectively is a lot of Olympic-sized swimming pools. In fact, it's about 1,600 or 800 on average swimming-sized pools of wastewater coming from residents. But ultimately, the design of this plant, and it's going through significant upgrades, great upgrades, one that will take this wastewater and treat it to near drinking water quality. And it's designed for in the future for about 1,600 Olympic-sized swimming pools per day. So we're dealing with a lot of flow and a lot of great improvements that will have an improvement on the local aquatic habitat. What this outfall project is all about is a brand new outfall going from the treatment plant itself, which is located about the southeast side of the city of Toronto. It's taking treated effluent and effectively conveying it out further, much further into Lake Ontario, out within the Ashbridges Bay. Now, it does involve a shaft that's about 85 meters deep. And for those who may not know, 85 meters is about a football field down into the ground, a pretty deep shaft. It's going to go then and transfer out into the lake about 3.5 kilometers or 3,500 meters. That's a little bit longer than the Golden Gate Bridge, and it will terminate in what we have is about 50 different risers, which culminates into a diffuser. And what this system will do will take treated effluent coming from the wastewater treatment plant, and again, treated with UV or ultraviolet disinfection technology. It's going to convey and disperse that treated effluent further into Lake Ontario, and it's going to comply with the federal and provincial regulatory requirements. And most importantly, it's going to improve the water quality along the city's shorelines. The existing outfall right now is nearing its service life. This new outfall, as large as it is going to last for the next 100 years. So proud to be part of this major improvement to the city. Now, an outfall itself, you might wonder, well, why is it this large? Why is it so big? We're going a football field in the ground. And the tunnel diameter actually is about a two-story house. If you drew a circle around it, that's how large our tunnel diameter is. Well, what we're doing is we're taking effluent, treated effluent from the wastewater treatment plant, and we're all conveying it by gravity. And what happens here is water is going to flow from the treatment plant down effluent conduit channels, and it's going to basically create a slight pressure differential right at the top of the shaft. And that pressure is going to push water down through the shaft, out through the tunnel, and up through each one of these risers. And at the end, we're going to have a port which helps disperse that effluent even further and basically disperse it on the lake at a much greater rate or a much greater dispersion than currently operated. Now, from a 3D visual perspective, we have our shaft on the left-hand side, but we also have a tunnel going well within bedrock, and then actually have these risers and even the liner around the tunnel itself, and a really neat and nuanced connection between the riser and the tunnel. So you'll hear me talk about these different components as we go forward here. I figured to explain again, why is it so large? It's because we have very little energy needed to push all this water out through the lake. Or out through the outfall. We spent a lot of time doing hydraulics analysis. So us engineering nerds that love this stuff, we can take our equations and things that we know, we can translate it to computer models and predict how much energy and head losses, I guess, losses that are required to push this water out through the outfall. And we're trying to do this without adding any other additional energy, letting gravity work its magic. And a lot of analysis went into making sure the hydraulics work. And in fact, these models look at little finite elements of water and how it conveys and how this gets, how the treated effluent then moves along the outfall into the lake. The other really important feature of our outfall is to determine whether or not the dispersion is making a big difference. And what's shown here on the screen is the receiving water impact analysis. It's effectively taking another type of model and taking the existing treated effluent as it's being conveying through the existing outfall. And you can see it on the middle there. It says existing diffuser. The existing conditions show that the treated effluent coming from the Ashbridges Bay treatment plant, you know, it does disperse, but it stays along the shoreline. And so the question is, well, how can we better improve the receiving water? And how can we prove, more importantly, that we're making a positive change within our local environment and supporting what Don just mentioned with the RAP? Well, as part of this receiving water analysis, we've done our modeling. And in fact, we have proven that as we push this water further into Lake Ontario and improve the hydraulics and dispersion as well, we're having a significant impact not only along the near shore of the Lake Ontario within the city of Toronto, but more importantly, it's showing that it's dispersing with a larger water body, and it actually dissipates a lot quicker by doing so too. So ultimately, we're making a major difference by pushing this treated effluent further in Lake Ontario. And not to mention, I mean, the Ashbridges Bay, again, treatment plant is making significant improvements to their treatment quality, but I'm not here to talk about the quality of water. I'll let the other team talk about that. I'm more going to talk about the outfall. And the sequence of work, I figured let's explain that, because I'm going to then go through a number of photos of how we've done this work so far. And one of the very first things that we do when we build an outfall, in this case, we're very cognizant of even the earlier acknowledgement of lands and waters. We want to make sure that any fish and fish habitat and the environment is protected as we do our work. So one of the very first and most important features that we do as part of this outfall project is to install a containment can and then a casing. And this containment can is lowered out into the lake, at which point then we lower down casings that are driven through the overburden or soil and then driven down into the bedrock. And we use large hammers, vibration hammers, to push this into the bedrock. And the containment can then allows us to work very effectively within a column of water without disturbing any nearby environmental features. In this case, we go ahead and then once those containment cans and casings are installed, we then excavate the soil and the overburden, and mainly sand and silty sands from the inside of that casing. And at some point we say, well, we can't excavate anymore. We've hit the bedrock, and yes, we've tried to take us as much as possible. We then realize we need to drill into rock socket. And the casing is no longer needed to go any further. We've created a nice seal within the rock as well. So what we do is you use very specific technology then to drill a rock socket, going further down into the bedrock to approximately just above where the tunnel is supposed to be. Once this entire casing is then excavated, both between the soil and the rock, and it remains flooded, we're then going to go ahead and install the riser pipe. Now, gosh, this is one of my favorite steps in the project, and you'll see a photo why shortly, but effectively what we're trying to do here is install a stainless steel pipe that goes down to the intended location where we're going to connect to our tunnel. And then we're going to grout around it. So then fill in the gap between where the casing is and the rock and the pipe. There's the annular space between the two. And we're going to put the concrete inside, and we're going to test to make sure there's not having any leaks. Once these pipes are installed, the riser pipes are installed and we've grouted, we're then going to take the containment can and casings out. And effectively at this point here, the in-lake water side of things around the riser pipes are effectively completed. The next step that we do is we want to protect these riser pipes, because once they're installed, they're going to be in for another 100 years. Particularly stainless steel, it's very hard to repair it underneath water. So we're going to go and lower down concrete maintenance holes, and we're going to protect the top of the riser pipes by doing so. All the while this offshore work is being done, we recognize there's an opportunity to excavate the shaft, and that's that 1 football field down into through the bedrock and the soil. And we're going to build that at the same time we build the risers. Now, here's where the scheduling concerns come in. The last thing you want to do is start to build a tunnel as you do in the risers. And so it's very important that we spend our time at the onset building these riser pipes, making sure they're all leak tested, because at some point we are going to tunnel underneath each one. The last thing we want to do is have any exposure or any risks to our tunnelers down within the tunnel and any water coming in. Ultimately, once these riser pipes are installed and we've tunneled underneath it, we can then go ahead and make that final connection between the tunnel and each riser. And you see it's a small little nuance here, but it's a really important one, because that's the final piece that kind of puts everything together here. Once those tunnels and risers are connected, we're going to build a large effluent conduit structure. That's a concrete structure. Those are basically 6 different lanes of highways that are transferring water from the UV disinfection facility to our shaft. We're going to build at the top of our shaft and make this final connection. This is all, again, done in the dry. At which point, all our work is generally completed. We're going to then flood the tunnel, get some divers out there, open up some valves, flood the tunnel, take some time to build up the water slowly. And then we're going to take some, and then one of the last steps is then to mount the ports. And these are small little nozzles at the end of each pipe. And once this work is all done, guess what? Our outfall is ready for operation. We could take the treated effluent from the wastewater treatment plant and convey it out in Lake Ontario. Now, from a construction update perspective, I'd love to show all these steps and photos, and gosh, we've got some wonderful photos from a great team that I'm working with here. We did start this project back in 2019. We worked on the edge of the shoreline here, and what looks like a pretty good space here actually turned out to be the right space. And in fact, we have a lot of great features that our team, our contractor, as they occupied the space, and the tunneler finally said to us, hey, Toronto and Hatch, you actually gave us enough room for us to build our tunnel. Usually we have a very small sliver of land. In this case, you've enabled us to use every inch. And in fact, as time goes here throughout the summer of 2019, our tunnel and compound starts to form. And what looks like a smaller space now has temporary shelters being built with sea cans. And on the right-hand side, stormwater management ponds to make sure that any water that we have on site is being generated and then treated and then stored within the site and eventually treated, pumped back to the wastewater treatment plant. So a nice little area that we can work on our own. That said, like I mentioned earlier here, as our sequence of work starts up and we want to build our risers. So at the start of this project, one of the first things we did was got out there with our jack-up barges and floating spud barges and started building those containment cans and casings, and then excavated outside of it. One of the purposeful things is we wanted to do the very last ones first, just to make sure that the ground that we did predict and did a lot of investigations was accurate, and that our tunnel didn't have to change, which this is from our end, our baselines hit the mark, and we managed to not have to make any changes during design. That's the last thing you want to do, but in this case, everything met our expectations. Now here's one of my favorite photos on this project. This is where the riser pipe, and again, each one of these riser pipes, about 50 meters, 45 to 50 meters in length. That's half a soccer field length. Each one welded all together, lifted up all at once, and then lowered down in. And I couldn't have predicted this as an engineer who professionally, designed this and stamped this work. But when you lower down this pipe, there's a neat little waterfall effect that occurs as the water cascades out, and the pipe is lowered into the water column in that excavated shaft. Again, you can look at the size of this compared to the workers in the background here. We're talking about some big stuff. So really neat to see this work being done in person. Once all the riser pipes are installed and grouted, the other thing that we wanted to do is go ahead and inspect each riser pipe with divers, just make sure everything has been installed. And here's a nice photo of what the riser pipe looks like from the divers operations, a remote operated vehicle. So again, this is what the end product is looking like before we install that riser or that port protection, that concrete maintenance hole. But this includes features like biofouling mitigation. And ultimately, this is where we're going to flood the tunnel using operating those valves there too. So pretty nifty stuff. And this is the final result where no one's probably ever going to see it again unless you throw it on a camera or have a diver down there. Now, back on the surface, as the riser pipes were installed and we get through that interesting challenge, at the end of the day, we wanted to build a shaft. Now, we're building a shaft through sand and on the surface, and we're building it right near the lake. So there's a very specific type of construction, and that involves shaft secant piles, where we've built a ring of concrete all the way around a big circle. And it's the intersection of these different piles that creates almost a concrete curtain that then allows us to dig down through the sand and not have any water come in. So it's a sealed type of construction, and in a way that we can build we can build our outfall shaft without having inundation from water. And here's a neat photo from a drone that looks straight down the rather large crane there. And that's one of the first efforts in us removing that sand. I'll be honest, the onset of this shaft excavation, we had 1/3 of the shaft excavated in 2 or 3 days because, gosh, sand's pretty easy to move around. But it does get tricky when we then get down further into the bedrock. And this is one of the first few photos of us going to start building the shaft within the bedrock. And again, there's certain attachments you can add to excavators that start to grind the rock. But what's neat about this photo is it shows what the bedrock looks like about 40 or 50 meters underneath the ground. In this case, you can even see the engineered system that has been designed on the side with a combination of wire mesh and rock bolts, as well as shotcrete. So as we dig down, we start to replace and support the bedrock around us. So a neat little photo here from the ongoing construction. Now, once we get to the final intended elevation of where we start our tunnel, this is where our tunnel starts to form. And this is what we call the starter tunnel heading. And this is where we build our shaft, or we start to go horizontally as opposed to vertically down through the shaft. Again, a really neat photo, and you can see, again, the size of this tunnel. This at the time, I don't have I can't say this anymore, but we're the second largest tunnel now, but at the time, this was the largest tunnel being built in Toronto. Here's another photo as we build our starter tunnel. Now, the interesting thing about our starter tunnel is what the contractor elected to do is try to go about 100, 120 meters past the shaft out towards the lake, and all within bedrock. And they built it in 2 sequences, one with the upper arch, and then finally getting the second one where there's a final invert. But it's very purposeful why our contractor and our tunneler did this. They wanted enough space to then assemble a tunnel boring machine all in one shot, as opposed to just building it one by one. So there's a slight change, but we worked with them, and ultimately we built a brand new starter tunnel that goes out into the lake. And one of the last steps of the starter tunnel is to get that right proper elevation where we can launch our TBM in the right direction at the right trajectory to go in and intersect the risers out in the lake about 3.5 kilometers away. So a lot of time was spent checking, and triple checking, double checking, and triple checking to make sure our alignment was correct. Now, here's a photo of a starter tunnel. I hope you all don't go away with thinking this is what every starter tunnel and every tunnel looks like within Toronto. I can guarantee you that's probably not the case. This is probably the cleanest tunnel that Hatch, our team, has ever seen in our entire careers and many other projects we've worked on. But I'd love to share this photo because it speaks to the professionalism and the quality of this contractor, and ultimately the intent on doing things right and building things right. And gosh, it's a very fantastic start when you see a contractor and someone building to the level of quality you can see in this photo, where it looks pretty impeccable. What you'll see in the middle there, those are 2 tracks, and that's where we're going to place our TBM as we build it. And it's going to go the entire length of the starter tunnel. At that point here, once the starter tunnel is built, we can then take the different tunnel boring machine components, all these major ones that were shipped actually coming from all across the world. A cutter head from China, the TBM itself came from Mexico, many different parts from, even apart from Germany, I believe, came too. So it was a worldwide adventure to take and build one of the largest tunnel boring machines locally here. And this was all done under the guise of night. In fact, you probably never saw it because it was always, every piece of equipment came late at night. And one of the neat things about installing a TBM is, well, this is what it looks like at the front, and this is the cutter head. This is it's not boring stuff because it's pretty cool stuff in my eyes, but ultimately this is the very front where there's disc cutters that will go and can work against the bedrock and start to break it apart and then convey it out through, ingest the bedrock and then bring it out through the tunnel boring machine out into the shaft. Here's what it looks like, and that's probably the last photo you'll see of the cutter head, because ultimately, once it's installed and pushed in front of the TBM, there's very little chance to see it ever again. In this case, most of the photos become more of all the big contraptions and the pieces, major components to be assembled together. In this case, here's an erection ring where we're taking a vacuum system that can then install the precast concrete tunnel liner. A lot of these components, again, come together here all at once, and we can test and commission this out all together. That said, I'm not going to spend much more time talking about a tunnel boring machine. I will hint this, is that we had a documentary on this project. And in fact, it was at this moment here, we had a very interesting event that took place. And I'd highly recommend, if you are interested, there's on the Smithsonian Channel, and I think it is, well, what it's called now is, it's a season called Impossible Repairs. You'll find it online. It's season 1, it's episode 6. The last one was the best one in my eyes. And it's called Big City Tunnel Boring. If you want to hear more about our trials and tribulations and leading up to the first time we started tunneling, go watch that video. It's very entertaining, probably overly dramatic, but I mean, it's a lot of fun. So take a look at it if you get a chance. That said, one of the first things that we did as we built our tunnel, and the tunnel boring machine works its way and starts to extract the bedrock and ingest it and move it out of the tunnel, we start to install what I said earlier here is a precast concrete tunnel liner. And that's effectively 6 different pieces that form a large circle or a ring. And as these segments are installed one by one, it creates an arch-like support around the perimeter of the tunnel as we build it out. And as each ring is built, then we push off of it and build and continue to build the tunnel going forward here. And I'll be honest, from here on in, most photos are very consistent. This is what it looks like. And it doesn't change other than you just notice a ring we're a little bit ahead before, but every photo looks like this for the rest of the tunnel. Kind of boring stuff, but it's really neat stuff. At the top there actually shows a yellow, that's where we get all our air supply within the tunnel too. But again, you can see the magnitude of this tunnel, how large it is just with this photo alone. The good news is we did complete our tunnel. And a little anticlimactic because it's not like your other tunnel projects where you get the hole through a second shaft. In this case, you know, we heard from the survey, I think we hit our spot. Oh, no, back it up a little bit. No, joking aside. No, we hit our final tunnel heading and we celebrated with a photo of us inside the tunnel, but this would never know, you wouldn't have known any different from any other photo as you do your tunneling. But it was a monumental moment here. We had some trials and tribulations. I'll save it for another date, but it was great to get our tunnel done and finally completed. Once the tunnel's done though, the tunnel boring machine, like I said before, we didn't have an exit shaft. We couldn't pull a tunnel boring machine out of a shaft, and we weren't going to do it out in the lake that deep below. So what we happened to do is abandon the TBM. That means removing every piece of major equipment, hydraulic hoses, oils, everything like that, and leaving only 2 things. And that's that cutter head, that one photo I showed earlier, that large piece at the front, plus a shield. And what happens here is the remaining components then are basically concreted in place. And we then filled a formwork behind it and fill it up with grout. And so this tunnel boring machine, at least just the big steel shield and the cutter head, is going to remain in the ground for the foreseeable future. It will be an ancient relic of human civilization at some point. And all we get to see here is concrete grout plus, at the end of the day, a final concrete wall. So, I mean, again, anticlimactic, but pretty neat stuff in my eyes. Now, what we're currently doing within the tunnel is we're building that really interesting connection between where the tunnel crown and each riser. And that's one of the first things we need to do, is to remove those concrete segments that I mentioned earlier here that create that arch-like support. Not only do we remove it, but we also then need to dig up through the bedrock and make our way up to the riser pipe that's just above us. So again, this is pretty big stuff. We have a number of platforms working in the background there. It's all done by, as I showed here earlier, it's all done by robot to reduce safety risks of workers. The last thing we want to do is have any excavation done with, and we're always trying to achieve no harm with what we're doing out there on site. But ultimately, you can see this is a rather large excavation being done to make a small but very important connection between the tunnel and each riser. This is what it looks like up close. In fact, at this point here, we're attaching hoses to the bottom of each riser because each riser is filled with water. And as we drain it out, this is my second most favorite photo on this project, we actually get yellow dye, or sorry, a green yellow dye that comes out of this. And that's very purposeful. We wanted to make sure we added a biodegradable dye. This is used in many wastewater projects, but ultimately we wanted to add dye there to make sure that when we drain that riser pipe, we know it's water that we've already placed and it's not coming from the lake. And this has given us the reassurance we need whenever we drain each riser. And we've had some, you know, it's pretty neat when you have a tunnel flooded with yellow dye, but kind of cool. And I don't think there's many other tunnels that have done this, but we did it on ours. It's been great success. Once the riser pipes are drained, we then remove the bottom riser plug. And then at that point here, we're going to go and attach some structural members and then finally build up the shotcrete and reinstate that concrete liner that used to be there, and eventually have a final moment here where this is our current status within the tunnel at a number of risers, where we have a pipe that kind of projects into the tunnel. We're going to trim it flush with the top of the tunnel crown, but this is where we're at right now. And we've got about 10 or 12 of them done. And so far, very great success from our team. No water, everything's going as intended. Meanwhile, I mentioned earlier with my sequence that we build an effluent conduit. That's that large structure that connects the UV disinfection facility and Ashbridges Bay treatment plant to the shaft itself. And that's what's underway as of the end of this year's, or end of 2022. We installed some dewatering and effectively got to a point where we installed a mud slab and a concrete slab for us to then go ahead and build pipe piles, which are basically large steel members that are being inserted into the ground to help support that concrete structure. And this, my friends, is probably one of the last photos I have of, and this was taken, I think, a couple of weeks ago. This is where we're at with the effluent conduit structure. You can see the final connection will be done at the shaft and make a final monolithic concrete pour at the end of the day. Last slide I have for you folks is our overall schedule. We started back in 2019. We have 4 solid years of great construction, great success, not only completing our tunnel, but also completing a number of tunnel riser connections with ongoing work with our effluent conduits. And even we're going to look forward to then building our final connections between the starter tunnel, tail tunnel, and then one day getting to a point next year, hopefully, where we flood the tunnel and have this outfall ready for its intended purpose. And without any further ado, I will end there and say thank you. Again, I mentioned earlier here, it's exciting to showcase the wonderful things that I get to be a part of, and my team. I mean, it's a blessing to work with them, doing some fantastic stuff, and to celebrate the great successes we had, because at the end of the day, you know, the positive change that we are going to bring to City of Toronto by this project gives me great pride and pleasure. And gosh, I'm very proud to be part of this project, and you can see it as well. So thank you for your time. If you have any questions, go ahead and shoot away. I'm here for the rest of the day or the rest of this meeting here. I'm happy to share with you anything that comes up.
Oh, amazing. Thanks, Kevin. I don't know if you can see all the thumbs up and the applause coming up in the bottom corner there. So that's awesome. You're also getting a lot of questions through the Q&A here. So I'll try to ask as many as I can. So maybe I'll go through these, and then maybe I'll ask that maybe kind of at the end, maybe you just sort of filter through them again. I know Vlad has been sort of filtering through them too and providing answers where he can, but I'll try to get to as many of these questions as I can. So the first question that came in was from Laura, And basically just with concerns is the moving of the risers kind of further out into the lake. Is that not just sort of moving the problem kind of away, but just sort of, you know, still having the same kind of problem, if that makes sense?
Yeah, so I'll try to answer it to the best of my ability. Again, my expertise from the outfall is more the tunneling and the outfall itself. What I do understand is the City of Toronto has made significant improvements to the treatment system process within the Ashbridges Bay itself, and that treatment plant itself. The one notable item here is UV disinfection added. So it's a new tertiary treatment at the end of the treated system. So that's underway right now. There might be an opportunity where maybe we can showcase that. I'll leave it to the city and whatnot, but I'm not going to make any promises there. But from the outfall itself, I mean, the existing outfall, the issue with the existing outfall is that as it is conveyed and dispersed out into the lake, unfortunately, as what's shown in my earlier slides here, the receiving water impact analysis shows that the dispersion is not quite effective, not nearly as effective as we'd hope. And that's something that we, you know, ultimately the treatment plant has been in place, and that this is working as this way. Listen, we can challenge the status quo, we can do better. And the new treatment plant improvements, along with the improved location of the outfall, will significantly reduce that, it will improve dispersion and will reduce the impacts to this near surface or to the shoreline along Lake Ontario there. So the proof is in the engineering and the dispersion modeling itself, but ultimately this will be a significant improvement to water quality within Lake Ontario when we're done.
Cool. And then there's actually just a couple questions that have just come in that are kind of around like water, sort of around what you've just said, but around water quality monitoring. So will water quality monitoring and things like that continue sort of post construction?
I believe so. So we do have an intent to do a final receiving water impact analysis and looking at our dispersion modeling versus what we predicted and what we have constructed. But ultimately, you know, the construction set, we're meeting the tolerances of what we had originally modeled. So we don't foresee any major changes. Ultimately, the dispersion that's predicted should be manifesting the way we expect it to.
Okay, and sorry, go ahead.
Oh, I see a question about what software. From one modeling nerd to another modeling nerd, there's a number of modeling softwares, but Cormix is one that I'd suggest you look at. There's a couple others that, I mean, shoot me a message if needed here or find me on LinkedIn. Happy to give you some more other models as needed too, but there's some very sophisticated modeling that's available out in the current industry.
Cool. And then a couple of questions came in just regarding just vessel navigation and things like that, and if those diffuser pipes or anything like that will cause, you know, just with the water, you know, coming out of them or the pipes themselves, if they'll cause any sort of issues with navigation.
No, actually, I'm more concerned about making sure I protect the riser pipes and ports from any ships. I mean, it has been designed to allow these ports. I mean, we're thinking about 100 years. We don't want any ships accidentally throwing down their anchor or disturbing the port, because it's going to, again, last for a long time. So I've done my best, and our team together have designed some robust protection around making sure that these ports are protected in the long term, and making sure that ultimately we're not disrupting the treatment plant at any time in the future. So a lot of thought went in protecting these ports and riser pipes in the future. It's more us protecting from others. That said, I doubt we're going to impact anyone when it comes to it. And like I showed you before, the riser pipe's going to stick up out of the ground, and unless you look down there, you probably won't notice a thing. And unfortunately, that's what typical engineers do. They do things out of sight, and we've done that, and you'll have a great product at the end of the day that's going to make some significant improvements to the lake.
Awesome. And then also just a couple of questions came in just with regards to the effects on local wildlife. So I'm wondering if you had noticed any like effects on local wildlife, or maybe if you could just if there's the measures that were taken to sort of, you know, reduce or minimize effects to local wildlife, if you'd be able to speak to those.
Yeah, sure. So is the local wildlife when it comes to aquatic habitat. Again, we worked within a pretty robust containment can, and not only within a containment can, we had a casing. So we almost had a double seal between where we're actively working and disturbing the sediment to then having a protection around local aquatic habitat. That said, I mean, our team of biologists did a lot of studies in advance to look at fish and fish habitat. At the end of the day, it was deemed that, I mean, where we were operating had very low impact to the aquatic habitat, but even still, again, we want to achieve no harm and protect our local aquatic habitat. And that's why we took the measures we did and specified the robustness that we had to protect any construction impacts to the local aquatic habitat. But that said, no, we haven't caught any major fish since we've started, and nor have we noticed any impacts to the fish and fish habitat. So, and within the surface itself, we might see an occasional fox, I think, that has come from Tommy Thompson Park that manages to wander into it. And yes, we have to do a toolbox and safety talk around that to educate our workers about how to handle wildlife. But other than that, it's pretty low key. We have our zone, we're working within it, and very little impacts we're seeing.
Awesome. And then a couple of questions as well, just with regards to if, as you were sort of drilling the tunnel, if you found anything like interesting, like any things like fossils, things like that, artifacts.
Yeah, so fun story. I guess I have a resident engineer I work with that has always said, you know, as we excavate down through the overburden, we might just find a Model T. And he said it in jest because, in fact, the area that we're working on, particularly around this Ashbridges Bay treatment plant, is actually built on a landfill. So the immediate surface features is, I mean, rubble, steel, bricks, you name it. We're going through, like I said, we could have seen a Model T if we didn't find it. So now he'll get me a 6-pack of beer, I'm sure of it. But ultimately, nothing new, nothing interesting, all pretty straightforward stuff. And even going through the sand was just instantaneous. Out in the bedrock, as we excavated the tunnel, no, all pretty straightforward stuff. Nothing major, no artifacts that deep at 85 meters. I'd highly doubt there's any anthropological remnants down there at that point either.
Awesome. Okay, well, thanks so much, Kevin. We do still have some questions and things coming in. So maybe if, and I see Vlad is also providing answers. So thanks for that, Vlad. So yeah, maybe if you don't mind just kind of going through and just sort of, yeah, that would be great. So yeah, again, getting a lot of love from applause and thumbs up and things like that. So thanks again, Kevin, for that. So
I appreciate the opportunity, Don. Thank you for approaching me on to do this. I really enjoyed this.
Yeah, no, happy to have you here. So we'll move on to our next presentations for this evening. So our next set of presenters are Vlad Petran with City of Toronto and Jet Taylor with Toronto Region Conservation Authority. Vlad has over 30 years of experience as a municipal wastewater treatment engineer and currently works as a senior engineer in Toronto Water's wastewater treatment section. He provides technical expertise and coordination of the large projects within Toronto Water's capital program and is the project manager, contract administrator of the Ashbridges Bay Treatment Plant Landform Project. And Jet Taylor is manager capital and special projects with Toronto Region Conservation Authority and oversees TRCA's waterfront flood and erosion mitigation teams. The waterfront portfolio handles the repair and maintenance of TRCA's network of 233 permanent shoreline erosion control assets and also undertakes large-scale waterfront erosion-related projects for TRCA's regional and municipal partners. So glad to have you both here tonight. So whenever I see you guys are already sharing your screens, so I will stop sharing my video and mute, and you guys can take it away.
Okay, thank you. I'm the first co-presenter of the Ashbridges Bay Treatment Plant Landform Project. This is a joint project by the Toronto Water and TRCA. Just a quick outline of the presentation. I'll go over the first bullet, the overview of city's wet weather flow strategy, and Jet is gonna take it away and go over a lot of the past, and the present of the landform, the history, the overview of detailed design, construction phasing, habitat compensation enhancements, and progress photos. I can't promise that the photos will be as interesting as Kevin's, but we'll try. The city's weather flow strategy started, well, it all began with the Toronto and Regional Remedial Action Plan in '94, which outlined a lot of measures to improve Toronto's waters and habitats, and with the ultimate goal of delisting city's waterfront as an area of concern in the area of Great Lakes. It generated in 2003 the citywide wet weather flow management master plan, which is a 25-year has a 25-year timeline, which includes a lot of projects to reduce stormwater runoff, combine sewer overflow discharges to the waterways, which ultimately end in Lake Ontario, and improve water quality and the ecosystem's health on cities' waterfronts. Under this wet weather flow management master plan, a lot of EAs were prepared and approved throughout the years. In 2004-8, the Coastward Cut combined sewer overflow, the Ashbridges Bay treatment plant in 2008, it started at the main treatment plant EA, which ultimately resulted in the construction of the UV disinfection facility and the treated effluent outfall pipe, of which you just saw the presentation. In 2012, the Don River and Central Waterfront EA was basically recommending a wet weather flow terminal pumping stage for the 3 tunnels, part of the Don River and Central Waterfront, handling all Ashbridges Bay incoming flows from the wet weather system, and the integrated pumping station was a natural continuation of the other pumping station that was supposed to replace the existing MNT buildings in service for a long time. So they were all combined into an integrated pumping station, pumping to the treatment plant of all flows that are coming down the pipes. And last but not least, the Ashbridges Bay Erosion and Sediment Control EA in 2014, which resulted in the construction of this landform. The current wet weather flows management in Toronto is they're taking the sanitary and storm sewers combined and conveys them through either gravity through Coxwell, the sanitary trunk sewer, or through MNT buildings to the Ashbridges Bay, which then treats them and discharges them into Lake Ontario. The future strategy is what we are building now for, is separating the stormwater flows, buffering in underground storage tanks or the tunnel system, and then to the integrated pumping station, and also maintaining the Coxwell gravity storm sanitary trunk sewer, pumping it to the Ashbridges Bay, and a portion of the stormwater to the high rate treatment, and then combined effluent sending it back to Lake Ontario. Just quickly, this is the existing Coxwell sanitary trunk sewer. This is the Coxwell bypass tunnel, which is being constructed. Technically, the tunneling has been completed. The contractor is working on the shafts and other parts of the system. The phasing may have changed, but there will be another tunnel, the Taylor-Messy tunnel, and then the Inner Harbor West tunnel combined with the future off-light tanks, and all the flows will be directed to the Ashbridges Bay treatment plant integrating pumping station. Just a quick overview, total 22 kilometers of tunnels integrating into one system, 12 storage shafts, 27 stormwater and CSO connections, offline storage tanks, 7 of them, will be part of this Don River Center Waterfront program, and with everything will be culminating with real-time control to regulate flows in the city sewer system, and a dedicated high-rate treatment facility will be constructed on the lake fill on the landform project in the real estate we created to this this project, and everything will once everything is said and done, will virtually eliminate CSOs in the Toronto Inner Harbor, Don River, and Taylor-Massey Creek areas. And before I hand it over to my co-presenter, this is an aerial pictures of the area of the Ashbridges Bay Treatment Plant before any of the Don River Center Waterfront projects started. No disinfection, no IPS, no landform, no outfall. That's the largest treatment plant in Canada, as Ken was saying, 818 million liters a day, with a peak factor of anywhere between 3 and 5. And without further ado, Jet.
Great. Thank you very much for that, Vlad. And thanks, Don, for the introduction. Hello, everybody. Thanks you for having me here. So I'm going to move on and talk a little bit more about the construction side of things. But first, I just wanted to walk you through some of the steps that led us to construction and briefly revisit the Conservation Ontario Class EA that we did. And then some changes that happened through the detailed design processes between the EA and the detailed design process, and then some of the approvals and then the construction. So you can see our step 1, 2, and 3 there. We're currently about halfway through step 3. So the objective of the Class EA for the flood or for the erosion and sedimentation component of this project was to identify a preferred solution that will mitigate the risk of navigation due to sediment erosion and deposition at the harbor entrance of Ashbridges Bay and Coatsworth Cut, while considering the various approved facilities, planning initiatives, and current uses in the study area, which Vlad just talked about. So the results of the environmental assessment, maybe first here, you see in the photo on the right, there's 2 different shades of green. The dark green are the components of the project captured in the TRCA environmental assessment, and those in the light green are those captured in the various City of Toronto environmental assessments. So the preferred alternatives provides the least impact to water quality in the recreational areas, the best integration of current Ashbridges Bay treatment plant operations and flexibility with the future ones, and decades of safe navigation without ongoing maintenance dredging, which is happening annually right now, and enhanced erosion protection. So following the environmental assessment, we moved towards detailed designs with the final product shown on the screen. There were a few noteworthy changes between the EA recommendations and the detailed designs, which are highlighted in red. The first was a shift in the central breakwater towards the west, which allowed for more habitat enhancements on the east side of the breakwater without spilling more into the channel entrance and impeding recreational boating. Secondly, the central breakwater was slightly reconfigured at its tip to widen the gap and stay outside of the right-of-way for the existing treatment plant outfall that extends between the landform and the central breakwater. And lastly, on the bottom left of the screen, while we were in detailed designs, there was severe damage caused in this portion of the shoreline along Tommy Thompson Park following the April 2018 wind event that many of you may be familiar with. And the erosion was pretty dramatic in this area. It completely took out a worn trail in this area. So we opted to add an additional headland and extend the landform slightly to the west to provide more protection to this vulnerable area. So it's a fairly large scale project. And as you can imagine, project of the scale, there are numerous permits and approvals that are required. So I've listed out some of the primary ones here, which are DFO, Transport Canada, and Ports Toronto. So through the process, our TRCA team, along with Aquatic Habitat Toronto, which you'll see listed below in the extensive consultation part, we work closely with DFO on minimizing and mitigating the aquatic habitat impacts of the project, as well as on developing offsetting measures to create new and enhanced habitat. The Transport Canada and Ports Toronto permits are more focused on navigation risks and limiting those risks. And we worked with them on such items as notice to mariners, updating mappings, and temporary and permanent navigation lights on each of the structures. So although the primary consultation component was undertaken as part of the EA process, we did continue through the detailed designs and into construction to consult with engaged stakeholders such as Tommy Thompson Park, First Nations, and local boat clubs. And also, as touched upon just previously, we brought this project to Aquatic Habitat Toronto numerous times in the planning and design process to get input from all the agencies that you see listed there on mitigation options and habitat enhancement opportunities. So landform construction phasing. So this shows the phasing for the construction project. And for the two breakwaters that you see on the right side, the pink one is the central breakwater, kind of in the middle. And then on the far east, the right side is a light blue one, and that's the east breakwater. For these two breakwaters, we retained a barge contractor to build the structures, given that both connections to the land are problematic from a land construction perspective. The larger central breakwater connects to a sensitive portion of the treatment plant that wouldn't be able to handle the volume of trucks and machinery delivering material for the central breakwater. And the east breakwater connects to Ashbridges Bay Park, the very tip of it, and it's a heavily used park with about 1.5 kilometer drive through Park Pass from the street. So both those components are being built by a barge contractor, fairly separate from the landform component on the left. So the landform component is being constructed by TRCA construction crews, and it was split into three distinct cells, as you'll see. The purpose of this was first to make it a little bit more manageable from a construction perspective, but more importantly, we need to have the area isolated from Lake Ontario before any filling of the shale material can happen. This helps prevent sedimentation into the lake, which would impact aquatic habitat and species. The landform was isolated in three smaller cells rather than one large one, as fill material was ready from the tunneling operations that Vlad mentioned, was ready to be placed, and the duration it would take to build out one huge perimeter would negate the ability to accept that available material right away. Further, having one large isolation cell is problematic from a construction and environment and wind perspective. It would leave the long perimeter very vulnerable to storm events and significantly increase the possibility of damage that would have to be repaired on an ongoing basis. So once the landform three perimeter cells were built and we started filling those cells, we moved the focus towards the headlands, which you can see, which project out perpendicular from the landform, and they provide a lot greater protection to the landform, and they also help retain the cobble beaches that are in between each of them. So now for our on-site aquatic habitat compensation. So historically, the Ashbridges Bay area was a large marshland complex, originating as a delta formation at the mouth of the Don River to the west. Before filling of the bay began in the early 20th century, the fish community was linked to the Don River watershed. Today, though, due to development and creation of the Ledgely Street Spit, it is open coast habitat characterized by extensive wave and wind action and cold water. So these are factors that we took into consideration when looking at habitat options. So as you can probably kind of see, if not maybe read, the text is pretty small. We've incorporated habitat components that are varied by type and location. So at the southern portion of the headland, we have cobbled beaches, which I just mentioned. They're retained between the headlands. So there's 4 cobbled beaches, and each of them will have woody debris embedded in them. And then just offshore, there are offshore shoals or reefs that are submerged, and they are of various size aggregate. Along the central breakwater, there's submerged structural habitat, which is similar to the shoals. And there's a submerged sunken tree field at the base of the structure. And then close to right where it connects to the treatment plant facility in the north, there's a shoreline naturalization area similar to a wetland. So just showing these in kind of a slightly different fashion and cross sections here. So the top image there shows the cross section of the cobble beach, and then the offshore shoal or reef. The middle image shows the wetland area at the base of the central breakwater. And then you can see the submerged logs just below, and just below is the vertical sunken tree field. All right, so landform construction progress. This slide, as you see, is a bit text heavy, but after this, we'll finish the presentation with a series of construction photos that'll help kind of show how things progressed over time. And I think they're going to be better than Kevin's photos, despite what Vlad says. So first, the perimeter berms, as I mentioned, they were built first. They were constructed using core material, largely, which we were able to get for free, which was fortunate, and then capped with larger material for extra protection. Once this was completed, we're able to accept excavated material from the Coxwell bypass tunnel, the treated effluent outfall tunnel, and the integrated pumping station. We were able to accept those in to fill the cells. So I should note the testing was done on all of this material before being brought to site, and then every 100 loads were set aside and tested on site to confirm that all quality control criteria were being met. The shale storage capacity of the entire landform, so cell 1, 2, and 3, is approximately 750,000 cubic meters. And being able to accept this volume of material so close to where it was generated was able to create significant cost savings and environmental benefits from not having to divert this volume of material to off-site disposal facilities, most of which are outside of the GTA. Okay. So now we're on to the photos. So we're going to go in order, a progression through the creation of the landform. So everything started, we got January 2020. We got a little bit of a head start on the access road, which you see running towards the top of the photo there. So we got started with that first so that we could, the idea of building each cell was to build from both directions, to build out from the one side and then from the other side and meet in the middle. This was going to maximize our time efficiency on completing the cells so that we could accept the shale material quicker. By June of 2020, so about 5-6 months, we completed the perimeter berm for cell 1, going at it, as I mentioned, from both directions. And we were at that point ready to start accepting our first load of material, which came here from the Coxwell tunnel. And the first truck came in July 6, 2020. So continued by October of 2020, we'd closed off cell 2. So I think you're starting to get a scale idea, I think, of the size of this project. It's about 17 hectares. And yeah, so our construction crews worked pretty tirelessly getting all these perimeter berms in place so that we could be accepting these volumes of shale from all the tunneling projects. While that work on the landform was going on, our barging contractor was building the eastern breakwater, which was done throughout 2020, throughout 2020, and substantially complete in December. So by the end of January 2021, so basically a year into the project, all of cell 1, which is our second to largest cell, cell 2 is the largest, but cell 1 was completely filled. On April 13th, 2021, the outfall tunnel, so from Kevin's presentation that he just did, got the first load of shale from that project. And then kind of a big day here in May 2021 is when we completed the final construction berm and completely isolated all 3 cells from Lake Ontario. And I really like this photo because it shows how much goes on at once on this project. So you'll see in the foreground, there's the excavator that is connecting it to the land. But if you look further out in the distance, you can see we also have 2 excavators building what is Headland 2 and Headland 3. So Headland 3 was built first, and there you can see there, kind of see. It's a little bit more built up. They're putting the armor stone on, while cell 2 is getting the core stone in. You can also see just in front of those in cell 2 that there's a dump truck unloading a load of shale. So there's a lot going on in this photos. We got a lot of land, a lot of space. We were able to allocate crews to get a lot done at once. So these are the headlands that you could see in the far distance, a little bit up close. So headland 3 there is completed, and the crews are working on headland 2. This was a bit of an interesting, Kevin was talking about the work out on the outfall, and the majority of the fill came from the actual tunneling down, but there was some dredging that was required out by the risers out in the lake that needed disposal. So instead of bringing it all to land and then trucking it to a disposal facility, we were able to facilitate disposal of this sediment, relatively small volume compared to the shale that we were bringing in. But through the perimeter berm, you can see there's a little tunnel, a little that goes through there where the sediment was pumped and then covered up with shale. So this saved a lot of time and money for both projects. So cell 2 was filled. It's kind of hard to see. It almost looked like cell 3 is filled here with the ice that's built up. But in January 2022, cell 2 was filled. Here's a good image of the central breakwater that's being constructed by our barge contractor. So to date, they have the majority of it built for the core, and they're going to be working on placing the armor stone on it throughout the duration of 2023. And the central breakwater is expected to be completed by the end of November of this year. You can see the progress of it here. We have basically 4 headlands going, almost all of it filled, and you can see the central and east breakwater in the far background. There's a good look at the central breakwater, how large it is. And we're continuing to fill cell 3. We expected to have that filled in the next couple of months. There's a little bit of a delay or shortage in shale material coming through, but we'll have that filled in the next few months. And that was the last one. So we have an acknowledgement slide here. There are so many people working on this project and doing great work, from construction, survey, monitoring staff, project management staff. Too many to list, obviously. So we just wanted to acknowledge the City of Toronto, primarily Toronto Water, everybody working on the project at the TRCA, as well as the Outfall Tunnel project team, the Coxwell Tunnel project team, and the Integrated Pumping Station. And that's it for the presentation, and we're open to questions.
Awesome. Thank you. Thanks to both of you. Yeah, and I'm not sure if you're seeing too, but again, lots of love coming from the audience, lots of applause, lots of thumbs up. So thanks very much. We do have lots of questions here, and I see our team of panelists has been working diligently to answer a lot of those, but I will ask some of the more, I guess, frequent questions. So a lot of questions coming in with regards to access, and if when this is completed, if there'll be sort of a trail system connected to TTP, and if that will be open to the public.
Yes, so there is. Do you want to go ahead, Vlad? Would you like to answer this one?
Yeah, well, I can start and you can elaborate on that. So
Sounds
of the, and I've answered one of the questions, but there were many questions coming. So a large portion of this landform will become plant operation property and will be used for the construction of wastewater treatment infrastructure, the high rate treatment, which is a plant in itself. But there will be a portion of the newly created landform on the west end. I believe it's about 2.5-ish hectares that will be appended to Tommy Thompson Park. And we're also working to the motions to, although it will be maintained city property, a small strip along the shoreline continuing to the south of the future HRT that will be made available to the public.
Yeah, so there'll be a shoreline trail in some capacity and extension of Tommy Thompson Park slightly to the east before the landform treatment plant facility there. We have a lot of work to do to get to what that exactly looks like. We're kind of not even really at the concept stage. We know it's going to happen and we're planning for it, but there's still got to be a lot of conversations on what it ends up actually looking like.
Yeah, to one of the last questions, will still be planted for wildlife? There will be planting, but because the large portion would be become plant operational property, they will be maintained for such purposes. The Tommy Thompson Park, I think Tisha will answer to that, but there will be planting over there.
Awesome. Thank you. We had a question as well. Which First Nations were affected, and was consultation done with the Ashbridges Bay work? I think Lisa provided an answer to this in the chat, but I'll.
Yeah, I was just going to say we have Lisa Turnbull here, who oversees our archaeology department and was also the one undertaking the Class CA process. So I think she might be best to answer that. Thanks, Lisa.
Sure, thanks. Sorry, I was just typing away, trying to answer all these great questions that everyone has today. So thanks for all of that. We did undertake a class environmental assessment process, and part of that process, we consult with all of the treaty holders in this area. But in addition to that, we have been really fortunate to work with Mississaugas of the Credit First Nation through their field liaison program. And what that involves is actually having members of their community come out and work collaboratively with our fisheries monitoring staff when they're out on site to do their monitoring. So that's been a really excellent partnership for us as we moved into implementation of the project.
Awesome. Thanks, thanks, Lisa. And then a question, Jet, with regards to your diagrams, will they be posted somewhere so folks can kind of zoom in and out of those diagrams?
Yeah, I think so. We have a lot of items on our website that can be looked at. There, I think there's drawings there as well, but I can follow up with a package of the habitat components and things like that.
Awesome. Okay. Thank you. And then another question, will the new extended headland at Ashbridges Bay Park have any effect on Woodbine Beach, knowing that the silt movement from the bluffs will be interrupted? So do you expect more sand or silt to be settling Woodbine Beach? So I think what that's referring to is the headlands, or sorry, the new forget what
breakwaters.
Yeah, like on the, or yeah, sorry, the short headland, I think, coming off of the Ashbridges Bay Park there.
Yeah, so the sediment in this area generally comes from Woodbine Beach and out to the west. So what was happening is it's coming around Ashbridges Bay and is settling in the Coatsworth Cut area, which is why we were needing to dredge it. We do need to dredge it still every year, that Coatsworth Cut, for safe navigation. So these breakwaters, the way they're configured, kind of come out to a little bit of a point, and it has the sand bypass the breakwaters, and we are expecting to have more sedimentation potentially on the landform headland area and the eastern side of Tommy Thompson Park. I'm not sure if that answers the question, but we're not expecting any negative impacts to Woodbine Beach.
Cool. Okay. Thanks, Jeff. And then another question about just the materials used and how they were tested for environmental safety.
Yeah, Vlad, you might want to get this one from the tunneling side.
I'll respond to that. So each of the contracts for tunnels in the city have specified strict strict specifications related to the quality of material. There's been a testing program at every generating site, Coxwell, Outfall, Integrated Pumping Station, in accordance with the current regulations. And in addition, every I believe 100 loads, TRCA sampling and is testing at the receiving site. So there's a double check happening from at the generating end and at the receiving end. And all samples were tested at accredited laboratories and are strictly in compliance with the lake fill quality requirements. So the quality requirements for lake fill projects.
Awesome. Okay, thanks, thanks, Vlad. And one quick question, if you know, who was the barge contractor?
It's Dorncamp out of Picton Terminals in Prince Edward Island area. HR Dorncamp, I believe. HR Dorncamp Limited.
Awesome. And then another question, just with regards to the smell coming off of the plant, is any of these treatment plant upgrades, is there any plans to help with the smell or help reduce the smell that you know of?
Sorry, I didn't get the last part of the question.
Just with regards to the treatment plant upgrades, and if there's any plans or anything being done to address the smell coming off of the treatment plants.
Well, any upgrades that will happen will definitely have an odor component will be designed to mitigate odors or minimize odors.
Awesome. Okay. Well, thanks so much. Thanks so much, everyone. Thanks for your questions. And again, there's still a couple questions, and I see again our panelists are working diligently to provide answers to those. So thank you. But we will move on to our last presentation for the night. So and our last presenter for this evening is Jet. So Jet, I've already introduced you. So yeah, so if you could just, whenever you're ready, just share your screen with your final presentation here, and you can take it away.
Yeah, let me just switch gears here to the other presentation.
No problem.
Sorry, everybody, you're stuck with me for another 15, 20 minutes or so. Sorry.
All good.
All right, so for this presentation, I'm going to talk about our TRCA waterfront major maintenance portfolio. And given that the theme of this evening is East Toronto, I'm going to focus on our Eastern Toronto initiatives. And I think I'll probably be back next month to talk about our Western Toronto initiatives as part of this portfolio. So for the agenda, I'm going to start off by discussing the waterfront major maintenance portfolio in general, including program framework, funding sources, and quickly go over the typical project life cycle of our projects. And then I'm going to switch to talking about 3 projects undertaken under this portfolio, 2 within Ashbridges Bay Park and 1 further east in Port Union. So for program framework, what we work under, so the Conservation Authorities Act mandates conservation authorities to manage risks associated with the natural hazards of flood and erosion. So this allows conservation authorities to establish and undertake initiatives to achieve this objective, including monitoring, remediation of areas affected by flooding, erosion, and or slope stability. So in response to this, TRCA has established the Erosion Risk Management Program to monitor hazards and implement stabilization works on a priority basis. So we do that all over TRCA's jurisdiction with various other managers and project managers dealing with the ravine systems, and I deal with my team primarily or exclusively on the waterfront. So our waterfront program is funded by the City of Toronto, and we have contribution from Infrastructure Canada as part of the Disaster Mitigation Adaptation Fund. So I wanted to put this slide up to give a sense of our project management team structure within the portfolio, which consists of 3 teams of project managers, project coordinators, and environmental technicians. But more importantly, I wanted to give credit to these amazing people that I'm fortunate enough to work with every day, and just kind of hopefully remind everyone that these large programs and projects aren't possible with real people working, without real people working collectively to achieve common goals. So thank you to all these people, if any of them are watching. So for our funding sources, our waterfront major maintenance portfolio is primarily funded by Toronto Water, with funding projected over 10 years and confirmed annually. The funding comes from 2 budget tables, with the bulk coming from critical erosion and flood works. And just for perspective, our 2023 budget is approximately $5 million. So as well, in 2018, after the high lake levels of 2017 and kind of during the large windstorm that happened in April of 2018, TRCA submitted a proposal to Infrastructure Canada's Disaster Mitigation Adaptation Fund, and we were successful in obtaining matching funding up to 40% of our eligible expenditures under the waterfront major maintenance portfolio. So through this top up to our waterfront program, it should allow us to work through our backlog of repairs and bring the majority of our 233 erosion control assets to a state of good repair by 2030. Before we get to the specific projects, I wanted to quickly go over our typical life cycle to give you all a sense of what goes into the planning of these projects. So everything starts with our erosion hazard monitoring team. This team annually monitors our network of, like I said, 233 waterfront structures to track their ongoing condition and inform prioritization and maintenance. As our structures are spread out from the very west of Etobicoke to the very east of Scarborough, the team uses a combination of drone flights and imageries, boat surveys, and on-the-ground monitoring. Once projects are established, staff move on to compiling existing baseline data conditions for the project area and filling in data gaps. Key components of this are aquatic and terrestrial inventories, archaeological studies, property mapping, and existing condition surveys. While this is going on, we're also preparing requests for proposal documents to retain coastal engineers to analyze the coastal conditions at the project site, to develop concepts for remediation, and then undertake detailed designs of the preferred concept for construction. Although we don't have coastal engineers in-house, we manage these contracts and work internally with Aquatic Habitat Toronto to develop site-specific habitat enhancements for incorporation into the detailed designs. While detailed designs are nearing completion, we begin working more seriously towards the permitting required to do the project and the procurement required for implementation. For our types of projects, we regularly need Fisheries and Oceans Canada approval relating to aquatic habitat impacts, Transport Canada approval relating to navigation concerns, and various municipal approvals relating to tree removals and park access. Procurement involves the securement of all material required for construction, including site setup items like trailers and washrooms and fencing, and then building materials such as various types of aggregate like cobble, riprap, armorstone, whatever the particular project requires. So once the projects are set up and essentially ready to go, our construction services team within TRCA takes over the day-to-day work of building the structures based on the detailed designs and incorporating the habitat components. While our construction has traditionally been done with material brought in by trucks, we have recently been using delivery by barge more frequently, as it can significantly reduce the impact to the terrestrial habitat and limit the impact to recreational park users as well. So once construction is completed, there are various reporting requirements, some of which are budgetary and program related, and others that are focused on conditions of approval and demonstrating that required habitat components have been properly incorporated and are functioning as intended. And then lastly, we have the arrow continuing back towards monitoring, as these newly maintained structures are monitored again to ensure that they are functioning properly, and our habitat groups continue to monitor the habitat components to ensure that they are succeeding. So that's the life of a project. And now we'll get to looking at some of the projects more specifically. So we're going to shift gears. I'm going to talk about two projects first within Ashbridges Bay Park. One that we recently completed and one that we are in the planning phases of for implementation either at the end of this year or early 2024. So the first one is the Ashbridges Bay Major Maintenance Project, and this project focused on just a single erosion concern that has been monitored by the Erosion Risk Management Monitoring Team since 2006 and has been listed as failing since 2012. So erosion of this failing structure was further exacerbated in the 2017 and 2019 high lake events, and also with the 2018 windstorm that I've mentioned. So some images of the concern here. The photo on the left shows significant backshore erosion following the April 2018 windstorm, which is when this structure was flagged as a high priority. Then as you can see on the photo on the right, as of 2020, the erosion was impacting the Martin Goodman Trail and increasing the risk to public safety. For the design work, Baird Engineering undertook the coastal analysis and the detailed design, which ended up involving a riprap revetment, which is highlighted on this slide, and also a nearshore reef in the minimally impacted area, which is kind of towards the upper part of the photo. So Galcon Marine Limited was retained to construct these two components, the revetment and the nearshore reef. And they mobilized in June 2021 and work began right then and was completed by October 2021, so rather quickly. And due to the high profile park and the high public use of the park, all material was brought in by barge, which was approximately 25,000 tons worth of material. The revetment is approximately 150 meters long, 7.5 meters wide, and is built of 200 to 900 millimeter sized riprap. And obviously the photo on the right here shows construction early on with Galcon kind of laying the base and getting the slope ready for the sloped revetment. The other component of the erosion protection is the nearshore reef, and it serves a dual purpose in that it provides protection against erosion of the shoreline by reducing wave energy, but it also provides quality aquatic habitat. So the nearshore reef is approximately 80 meters long and 20 meters wide, and it's built of 300 to 900 millimeter size riprap with the larger material out lakeward to protect the smaller material. The crest of the reef is at average lake level, so 74.8 meters, so that it is high enough to provide adequate erosion protection while allowing it to be submerged and therefore better fish habitat when lake levels are above average. A navigation light is atop the reef as a navigation precaution. And the photo on the right, you can see the construction barge. And then if you look closely in the near shore, you can just see the underwater reef slightly there. So as I mentioned, the project was completed in October 2021. The trail we had to wait until the following year due to the weather, and it was repaved in July 2022. There's some final restoration and compensation plannings that are still to be done, and they're being undertaken by City of Toronto's Urban Forestry Renewal Group. And staff will be continuing to monitor the functionality of the reef for at least 3 years, but probably longer. 3 years is what's required as part of our Fisheries Act authorization from DFO, just to ensure that the habitat components are functioning appropriately. So with that relatively recent project completed in this area, I thought I would discuss one that we are currently planning for implementation shortly, directly east of the previous one. And this one's titled the Ashbridges Bay East Headlands Major Maintenance Project. I feel like we got to get a little bit more creative with our project titles, but. So you can see the image here, the location of it. The project area is approximately 680 meters of shoreline, and this one includes 3 erosion control structures that were constructed in the 1970s, including the beach in the middle in the red, that is a high risk priority, and the 2 headlands that are medium, low risk priority. So the beach is comprised of concrete rubble mostly, and some scattered gravel and sand that extends to the near shore, but it's mostly just a concrete rubble beach. The headlands are comprised of various sizes of armor stone, ranging from 1 to 8 tons on the slope, and then we also have armor stone that's been displaced and is scattered amongst the near shore. So these two photos kind of show the concerns of each, the headland and the beach. So the picture on the left shows armor stone displacement and significant voids in protection. This leads to further movement and greater instability. So generally you want more of a tight, compacted armor stone revetment where everything's together, there's no voids, stops overtopping, and then waves or water receding back out and pulling out fines underneath. So what you see in the left is a failing headland structure. And then on the right shows the concrete rubble beach. So barely really a beach at all. And this material, just on the fact of it being concrete, is susceptible to breaking down over time, which lessens its protective ability. And just in general, it doesn't provide a whole lot of protection to high winds and associated waves. I'll also note that there's trails and walkways that run along the shore behind the existing protection for the majority of the site. And some sections are located close to the crest of the headlands and have experienced damage due to wave overtopping. So we're in the detailed design phase right now for this, and the proposed design includes the reconstruction or repairs along the whole length of the project shoreline. So most of the work on the headlands will be relatively minor, and will involve adding material to the existing structure to kind of fill in the voids, and then placement of additional riprap and armor stone on top of the existing material for greater resiliency. The beach, the existing pieces of concrete with steel rebar protruding, which happens a lot on sites built a long time ago, they'll be removed, and then natural round stone will be placed on top as the new beach material. So for the habitat component, so in this area, there have been aquatic monitoring runs since the year 2000. And the table on the top left shows the limited number of species caught over the last 10 years at this project site. So this data shows that the fish community is not only limited, but it's also heavily comprised of non-native fish species. So in consultation with Aquatic Habitat Toronto, we're proposing a surcharge revetment that incorporates fish habitat and minimizes navigational hazards. Navigational hazards are a bit of an issue in this area and kind of negate some of our other more inventive habitat options that we might include just due to its proximity to all the boating facilities in the Ashbridges Bay Coatworth Cut area. But there's also some boating facilities further down east of Woodbine Beach. So we didn't want to go too wild with habitat components out further off of these headlands, for example, as they are often navigated around. So the red circle there and the design drawing on the left shows the location where the habitat would be put in the project site, and the image on the right shows an illustration of it. So each surcharge area is approximately 150 square meters with 400 to 800 millimeter riprap stone, which can provide refuge to fish from wave action and hiding places for both prey and predator species. And that was the last one for that Ashbridges Bay project. Lastly, we're going to go through quickly our Port Union Phase 1 beach curb major maintenance project, which is located Port Union out in Scarborough. So as I just said, the project is located in Port Union in the Village Common Park, and it's the furthest west structure of the Port Union set of waterfront structures, and it's directly east of Highland Creek. The beach curb protects the waterfront trail and the Metrolinx rail berm and corridor behind. Interim work was completed in 2018 and included filling voids behind the wall and repaving part of the trail. The temporary solution was just to ensure that the waterfront trail was safe while long-term designs were prepared. So long-term protection designs were developed in 2021 with final permitting into spring of 2022. So key erosion hazards at the site include impact to the waterfront trail due to overtopping, freeze thaw, and washout, loss of beach curb stones causing settlement, voids, and instability, uneven pavement causing safety issues for trail users, particularly cyclists in this area, and eventual impacts of rail or to the rail berm and corridor behind the trail if left unmitigated. And given the proximity to this Metrolinx berm, trail realignment in this area was not possible, as it sometimes is in other areas where there's erosion concerns. So beach erosion. So beach curb mechanics rely both on shoreline armoring as well as wave dissipation. So loss of sand during the high lake levels of 2017 and 2019 resulted in the beach curb now being fully exposed to wave height without dissipation, causing erosion of the waterfront trail and damage to the beach curb. So essentially prior, you can see in 2015, photos could be a little bit better for this, but the beach in 2015, it ran wide and long across the whole beach curb. Following the high lake events, a lot of the sand was lost out into the lake and moved down along shore. And now it's essentially just the beach curb, the armor stone that you can see on the left side, without the beach in front of it to dissipate the wave action coming in. So it's just hitting a vertical wall of armor stone with nothing slowing it down before it gets there. So given that the beach has been washed out by the high lake events, there's a need to install something more robust that doesn't rely on the presence of a beach. So we talked a little bit about barging in the previous one. We're going to go a little bit more detailed here about barging material. So there's some access constraints for this site, including bridges, tunnels, and the Metrolinx berm to the north. There were limited places to truck materials or equipment, and the closest access point for trucking material was 1.7 kilometers away. So we did some advantage and disadvantage of trucking and barging material. So the advantages of barging the material include decreased trail closure, as we only needed to close the immediate work area. And this is a heavily used site for both pedestrians and cyclists. Reduced terrestrial impact to the trees and other vegetation. Reduced repaving of the waterfront trail. We would just have to repave our actual little work area rather than the 1.7 kilometers worth of trail. And ability to receive substantially more stone at once. A barge can carry a lot more stone than a truck, and this improves construction efficiency. Disadvantages include there's generally a higher cost than trucking. There's often limitations with appropriate docking sites, especially in shallow water, and limited vendors actually in the GTA for marine aggregate supply. So we did some analysis on this, and we decided to go with barging of material for this. And some of the main reasons why were the limited truck access that was far away from the site, the inability to schedule regular Metrolink crossings at a single access point. This was a large one. It wasn't a regular crossing that any vehicle can go over. It was kind of a more gated, protected crossing, which required a lot more coordination and risk with Metrolinx to ensure that everybody was safe with crossing the tracks. We were able to do that with our heavy equipment to get them on site, and then, but bringing in hundreds and hundreds of truckloads of rock across that was going to be problematic. Also, there's significant reduction in the impact to the heavily used waterfront trail, as I mentioned. And at this site, we did have sufficient depths to accommodate a barge, and we were requiring sufficient volume of material that kind of interested marine vendors a little bit more so we could get competitive bids. So this was basically a small armor stone revetment that was built along the beach curb to provide protection for it now that the beach is gone. So I'll talk a little bit about how it was created, given the theme of the evening. So the revetment is 280 meters long. It's mostly 15 meters wide, but we do have a habitat component, which we'll talk about next. And at the habitat components, it extends out to about 25 meters wide. And it was actually built on top of the beach curb just for stability purposes, as the previous beach curb, or the existing beach curb, did have stability issues, which is why we were doing the project. So the revetment was constructed by first building an access road from where the barge material was brought in from the east into the west. And then from there, we had the largest stones placed at the toe of the structure to help limit material loss on the access road, because we created an access road with cobble material and we wanted that material not to be washed away by the lake. From there, the structure was built upwards from the toe with core material, so cheaper material than the heavy protection material. And the core material was then capped with the 1 to 2 ton armor designed by our consulting engineer. It was capped as it was built up, and then we progressed from west to east. So the existing beach curb was adjusted as necessary during the construction to help ensure the stability of the material that would be on top. And then lastly, any remaining voids that there were between the 1 to 2 ton armor were capped with filler stone to provide further protection and also improve public safety if people wanted to try walking on it. So for this, we have, for aquatic habitat here, we did submerged groins. So like the other projects I've talked about this evening, this part of the shoreline is considered open coast. So there's a low propensity for habitat, and we're trying to create more. So habitat discussions for this project site recommended mixed size substrate and a preference for rounded stone instead of angular at this location. To this end, we've installed what we call submerged groins, which are similar to the surcharge revetments of the previous project. These groins extend out a little bit further than the submerged or than the surcharge ones of the previous ones. And they're predominantly for habitat purposes. They do offer minimal erosion protection, but the primary purpose of them is to create aquatic habitat. And the groins are constructed with larger armoring on the outer edges to promote stability of the smaller mixed sizes of stone in the interior. And the structures have the potential, especially the way they're spaced, to encourage sand retention on top of or in between some of the groin structures, and hopefully potentially start to build back some of the beach that was lost. Lastly, this is the final slide and the final product, and I think it gives a good reference of the proximity of the trail and the shoreline treatment to the Metrolinx rail corridor, and kind of why this work had to happen. Yeah, so that is it for me. Again, until next month.
Thanks, Jet. So a few questions have come in for you here. So yeah, we'll try to get to as many as we can. We still have a few minutes left here. So with regards to the habitat, and I think you answered this a lot in your discussion about the surcharge revetments, but do the revetments provide habitat for aquatic and terrestrial aquatic life, and what species do you expect will be using them following completion?
Yeah, so like the revetments in general, generally a revetment in general doesn't provide a whole lot of habitat opportunities. Often the big ones that we have to do in Toronto, given the urban development and the limited space that we have, we usually have to use larger armor stone, which isn't that conducive to fish habitat, which is why we work with Aquatic Habitat Toronto. And some of the options that we have in those cases are what was mentioned as surcharged revetments, where we add smaller cobble material or round stone or angular stone to the base of the revetment to start kind of building up appropriate habitat at the base, even though the revetment doesn't provide habitat. Because of that, we incorporate more. And the type of stone we use, the type of size stone we use, a lot of those are variable based on coastal conditions. You need to have large enough stone that's going to stay in the area if it's subject to a lot of heavy waves and that. So that's sometimes a limiting factor. And then depending on the site conditions, most of ours are open coast. Some are a little bit closer to river mouths. Some have embayments close to them. So depending on the site specifics, we target certain types of fish. And Dawn, you would be able to answer this a little bit better than me, but for each of our projects, that's why we go to Aquatic Habitat Toronto. We talk internally with our experts, and each habitat component is kind of tailored to the specific area where it is, coastal conditions, fish that are using the area, warm water, cool water, embayments there, mouth of river there. All those factors go into which species of fish we're targeting with our habitat components.
Yeah, perfect. Yeah, then so I guess just to build on that, yeah, we're utilizing the data sets that we have available to us and the data that we've collected just to get an idea of the fish that are commonly in that area, and then like you said, just trying to tailor the habitat components to them. So thanks Jet. And then as part of the East Headland project, will the little cobble beach that is there now, will it remain there?
Yeah, so the beach that's there for the East Headland project, a lot of it is concrete, weathered down concrete. So we're going to remove all the dangerous parts of it, any of it that has rebar protruding from it or that we know has rebar within it, that wave action will cause the rebar to be exposed in the future. And then the treatment for that beach there is actually a cobble beach on top. So we're going to add more cobble beach on top so that it has the weight and the size requirements to make sure that it's stable and that it's not moving and that it provides erosion protection to the backshore. So the cobble beach will remain and should be enhanced.
Okay, thank you. And then the with regards to the material, so for the armoring material and revetment material, where's that being sourced from? And are there environmental considerations undertaken in its procurement?
Yep, so we put our tenders for aggregate out publicly, so anybody from any quarry or any location can bid on them. Generally, I'd say the majority of ours comes from the Kawartha areas. We get some from the Milton area as well, but they really could come from anywhere. That's generally just where our frequent suppliers are located. And yeah, environmental considerations is a big point. So I mentioned in the beginning that these major maintenance projects are funded in part by Infrastructure Canada's Disaster Mitigation and Adaptation Fund. So a part of the requirement for being successful in that fund is looking for ways to reduce greenhouse gas emissions. And obviously trucking from the Kawarthas and that and the heavy machinery that we use on site, they are producers of that. So we've taken a lot of steps in our procurement documents, the wording that goes out, and we've been working, and we have worked with our heavy equipment operators to get more eco-friendly fuel for their operations. So these are considerations that we take into. Sometimes I don't like to say our hands are tied, but sometimes like we need to get rock to our site. I will say too, not far along on this at all, but we are starting to look into, so it's preliminary, different ways to provide this type of erosion and protection rather than necessarily relying on quarry stone, whether we can have some manufactured concrete that doesn't contain rebar, that can have the right weight, the right shape, rather than having to quarry and truck from far away. So we keep trying to progress on this to lower our environmental footprint. But at the moment, yeah, we do get our material from rather far away, unfortunately.
Okay, thanks, Chad. So another question with regards to Woodbine Beach and the flooding. So the flooding of Woodbine Beach in 2015 to 17 was alarming. Do we expect more events like this in the decades ahead, or will these project efforts protect us from future flooding? And also, what's the timeline for completing the Woodbine Beach upgrades?
So am I to assume that the Woodbine Beach upgrades means the shoreline works I just talked about at Ashbridges? Because, yeah, to those I can answer to. I'm not sure. I don't think there's any plans to raise Woodbine Beach to above flood levels. So any flood events that do happen in the future, I would expect Woodbine Beach to remain flooded. But all the work that we're doing now, so following 2017 and the 2019 High Lake events, the 100-year lake event elevation was raised based on those two major events. So all of the structures that we're building now, we're building to a higher elevation. Generally, we have 2 layers of material rather than a singular one, which was used in the past, but we're raising our structures higher. We're providing a little bit more of a backsplash if there is any overtopping, but essentially we are designing all of our structures moving forward to hopefully reduce the impacts of flooding and erosion by expected. I think there's going to be this consensus kind of, I'm not a predictor of climate change by any means, but the consensus seems to be that there may be higher highs and lower lows and more severe storm events. So we're building our shoreline structures a little bit differently now to be more resilient, to be able to withstand those future potential problems.
Awesome. Okay. Well, thanks. Thanks so much, Jet. And yeah, and I see that a lot of the questions as well are being answered by our panelists there. So again, thanks to our panelists, team of panelists for fielding those. So yeah, I think that's about all we have time for tonight. So thanks again. To everyone, to all of our speakers for presenting on your amazing work tonight. Thanks as well for our speakers, and again to our panelists for answering those questions in the Q&A. Thanks to everyone for joining us tonight and for participating in the Q&A. And as mentioned at the beginning, the recording of this event will be posted within the next few days or so on our Toronto Region RAP website under the Events tab. And if there were any questions that we weren't able to get to tonight, or you think of anything after the event, again, you can reach out to me directly at don.little@trca.ca. And yeah, please look out on our RAP website, social media, and our TRCA events page for our next event, where we showcase projects in the West. And that again will happen a month from now on March 23rd. So thanks again. Vlad, you have your hand up. I'm not sure if you want to.
Yes, I do. I just have
okay.
one little, I think there was somebody who asked a question about the non-motorized activities water access for the landform. I don't believe that is what we have provided for. And I would also like, if possible, to share my screen for a second.
Sure.
Whoever would be interested in the city's stormwater management projects, there's a QRF on our page, on our last page. I'm not sure if you can see it now.
Yep. Yeah, the QR code, you mean?
Yeah, QR code.
Yep.
Yeah.
Yep.
Pardon me. And that would be leading to the City of Toronto stormwater management projects, and there's a link there for Don River Center waterfront projects. So we can leave that for a few more seconds.
Perfect.
Thanks, Vlad. I forgot to direct people to that. My mistake.
No, that's okay. That would answer more, they'll provide more context and more details on many other projects. So I'm going to stop sharing now. That's all I have.
Okay, great. Thanks, Vlad. And again, thanks to all of our presenters, and thanks to everyone who participated tonight. So thanks again, and yeah, have a great night, everybody.
Hi, everyone.
Good night.